The builder pattern is intended to isolate the application code from complicated object construction. So if we have objects that require multiple steps, we don't want to repeat that code in our application. We'd prefer to have it in a separate class where we can deal with it there, and it doesn't overly complicate the rest of our application code. One of the ways you can make your code more supportable is effectively isolate areas so that the code is not so long that it's overwhelming. The builder pattern helps in that area. In this example, we're going to use a builder pattern in conjunction with an abstract factory pattern. So if you haven't taken a look at the abstract factory pattern, I urge you to take a look at that. Our abstract factory that we're going to be building consists of a database class. So we have an abstract class for database, the command, and a connection property. And then we have concrete implementations of the database class for OLEDDB and SQL Server. And of course, they also have the command and connection properties. We have an iDatabase Builder interface. And iDatabase Builder defines the methods that are going to be used to build up our database object and a property for its return. So we have a database property that we're going to be returning and methods for building the command, the connection, and setting settings. We have classes that implement iDatabase Builder for both SQL Server and OLEDDB. They return the database object and have the build command, build connection, and set settings method, as well as a constructor. And the same pattern is followed in OLEDDB Database Builder. And at the top of it all, we have a director class. It has one simple method called build. And what build will do is it will call the builder, and the builder will run the rest of the commands. So let's take a look at our database abstract class. It's very simple. It has two properties of type dbConnection for the connection property and of type dbCommand for the command property. Our implementation of database for the SQL Server database returns that dbConnection object and has corresponding members for that connection object, as well as the command object. If you remember in the abstract factory class, we did a little bit of work in the gets for both the connection and the command properties. We're not doing that here. It's actually going to be done in the builder. So we've actually simplified these classes as well. At this point, the database classes are basic storage classes. They don't really have any active code that's doing anything. So the command also just gets and returns the command member. The OLEDDB database class is the same way. It has members for dbConnection and dbCommand, and then properties for the connection and the command, and it just simply returns them. Now let's take a look at iDatabase Builder. The interface calls out the three methods that we're interested in: build connection, build command, and set settings, and has a property of type database that is a read-only, so it only implements the get. So we're using an interface, which means any classes that implement this interface must implement these methods and this property. And these methods are the steps that we're going to be using to create the database. So our SQL Server Database Builder class implements iDatabase Builder. We have a private member of type database, and in our constructor for SQL Server Database Builder, we create a new SQL Server database and set our member equal to it. So now we have a database that we can work with, and now we're going to call the methods to set that database up for use for the application. The first method that should be called is called build connection. And we're going to get the connection string by calling configuration manager and getting the connection strings array. And we'll look for the SQL Server connection string in the connection strings collection. And when we get it, we'll get its connection string property. And these connection strings are stored in appconfig under connection strings, and I've put one in for SQL Server connection and OLEDDB. And you can see that the provider name is SQL Client for the SQL Server connection string and OLEDDB for the OLEDDB connection string. In order to use Configuration Manager, I need to add a reference to system.configuration. This is a Windows app, so those connection strings are stored in appconfig. If it was a web application, they would be stored in webconfig. So now we've got our connection string. With that, we'll create a new SQL connection, and on our database, we'll set the connection property of the database equal to that new SQL connection that we created with our connection string. Now we're on to the next step called build command. We'll first create a new SQL command object, and set our database's command property to that object. And then we'll go into that command object that we just created and set its connection property equal to our database's connection that we built in this first step. So you can see that these steps need to be executed sequentially. The last step in this construction is setting the settings. So I go into my database's command object and set the command timeout. As you can see, I'm expecting some fairly lengthy execution. Then I also go into the command and set its command type equal to text. So we're only allowing ourselves to write SQL right in code. Your mileage may vary on that approach, and again, we'll be talking about writing SQL in code as opposed to using LINQ in best practices. And finally, in our public database property, we return our database member. And obviously, we want to go through all the methods to build the database member before we actually call for the GET. So that's the SQL Server Database Builder. The OLEDB Database Builder is effectively the same, except that it's going to create an OLEDB database. It'll build an OLEDB connection, an OLEDB command, and from there, set the command timeout and the command type, just as we did before in SQL Server. So there's no real differences there, except that it's calling out the OLEDB objects instead of the SQL Server objects. So those are our builders, and the important thing with the builders is they've laid out the methods for construction of the object. So now we have our director class, and the director class has one simple method. It's called build, and we're going to pass in an iDatabase builder. Note that we're typing the parameter using the interface as opposed to specific SQL Server or OLEDB builders. So we have an iDatabase builder object for a parameter, and when we call build, on that builder object, we're going to build the connection first, then the command, and then set the settings. So this is the class that will isolate the application code for multi-step object creation. Now this isn't too bad because there's only 3 steps, and of course the steps had some more steps to them within their methods. So if you flatten this out and said, okay, I'm going to have one method that's going to create my SQL Server command object, then you would run a build connection, which would have to go out to the configuration manager, get the connection string, build the new connection, then you'd actually go through the steps to build the command and set the settings. So instead of these 3 methods, you'd have maybe 10 lines of code instead of 3. And those 10 lines of code would be repeated in your application anytime you actually needed a command object. You really don't want that in your application. So what the director allows you to do is just create a builder, and anytime you want the command, call one simple method called build on the director object. So that keeps your application code nice and clean. So let's see that clean application code. Here's our form, and it's very simple. We have 2 radio buttons, one to use SQL Server and one to use OLEDB. And then we have a button to get our database object. When we click the button, we create a director object. And we get an iDatabase builder interface. And depending on which radio button was checked, we either create a SQL Server builder or an OLEDB database builder. Once we've typed that builder object, we take the director and we call build using the builder. And then from there, we just get the database property off of the builder, and we have our database, and we can use it in our application code however we want. Here I've just shown a little example of grabbing the DB command, running some command text on it, and I don't actually need to set that command text property in this case. Opening the connection, creating a data reader. I would obviously do some reading in here, and then close the data reader, and the connection. The important part of this is that this code is the application code. It knows nothing about the process of building up the database connection and command objects. It knows nothing about SQL Server or OLEDB or any of that. It only needs to know, I want to run commands, and here's the commands I want to run. So it cleans up the application code and gets it away from some of those lower level details that it shouldn't be concerned with. So the builder can be used to isolate application code from more complicated construction that shouldn't be in the application code. And we also use the abstract factory to isolate our database type from the application code. So again, we're simplifying the application.